The origin of the Earth's magnetic field is one of the great unsolved problems facing physics by Albert Einstein. But today, we know it is caused by the convectices in the outer core. Any beginner geologist would know that the Earth is divided into different layers, and they can be pretty different in the physical states. From the center, we have the inner core, which is a hot, dense ball, and it's mostly composed of iron. The liquid upper core, and it is mostly composed of iron and nickel. The semi-solid lower mantle, the solid upper mantle, and the outermost layer crust, the solid brittle shell.
How do we know if it relates to the bottom of the Earth?
It's indeed a good question, and in today's presentation, we're gonna know about this.
Honorable teachers, my fellow classmates, seniors, and the organizers of this beautiful event, Assalamu alaikum everyone. Myself, Ridwan Ahmed Jim, and
I'm Ridwan Sakib, and today we're going to talk about seismicity and Earth's subsurface velocity.
The question comes, what is seismicity? And the screen says, the frequency, intensity, and distribution of earthquakes in a given area. And this thing called seismicity is measured by seismograms, which collects data from the movement of lower land masses. And not only geologic events or natural events can cause influence seismicity, but also human activities like drilling of oil and gas can influence our seismic activity. Earthquake, right? Like you be chilling at your home and suddenly you feel that hitch up in you look up and you see your ceiling fan shaking. Oh, the tense moment, right? No. This earthquake is basically vibration. And the vibration, which is of a systematic propagation, is called waves. Seismic waves are those waves that travel through or over Earth. And these seismic waves, let's take a look at the classification of seismic waves. First of all, it says body waves. And body waves are those which travel through the Earth's body. And the surface wave travel along the Earth's surface. And among those, body waves are the faster waves. Let's dive a little bit deeper. P wave, the compressional waves where the vibration of the rock is in the direction of propagation. Interesting fact is, these P waves are the fastest waves among all the seismic waves, and these can propagate through solids and liquids. And the other one, the S waves, these are not that much fast, but can propagate through liquids. And surface waves which travel along the Earth's surface, one being lava wave, which tells us surface waves are pretty much romantic. Lava waves, and the other one being Rayleigh waves and poetry waves.
Earth's subsurface velocity. Now let's come back to the first question. How do we know about the interior of the Earth? The brief answer would be knowing the seismic waves behavior as they move through the materials, different materials, and learn about the layers that make up the Earth. Let's look at some behaviors of the seismic waves. Let's look at the P wave when it moves through the mantle. It travels in a simple curved bed and it constantly gets refracted because the mantle has a decreasing viscosity along its depth. This is the P waves. They move about 103 degrees from its epicenter, and we cannot find any P wave that moves through the mantle but beyond 103 degrees, because when it moves beyond 103 degrees, it is interrupted by other layers, like the outer layer, outer liquid core. In the mantle outer core boundary, it gets sharply refracted, and we can find these P waves which move through mantle and outer core just about 140 degrees. And the third case of P wave, when it moves through all the boundaries, all the layers, and it moves slower in the liquid outer core, but it gets faster when it encounters the boundary of the liquid outer core and the inner core. because inner core is more solid. And the same rays, and these rays we can find about 150 degrees from the epicenter. And the P wave has a shadow zone around 160 degrees to 140 degrees, as you cannot find any P waves that is direct and is present in 160 degrees and 140 degrees. And again, the S wave is a shear wave, and they move just like P wave, but they cannot move to the liquid outer core because S wave, obviously it's a shear wave and liquid has no shear strength, so acid cannot propagate to the liquid outer core. And that gives the S wave shadow zone that is around 103 degrees from the epicenter. And if you see in the graph, we can say that the P wave slopes down and the S wave gets extinct along the D level, which is the lowermost portion of the mantle. And that is the place where, and that's where the, let's keep this part. And the P wave gets lower and the S wave gets extinct because this is the liquid outer core, and in the next part, in the inner core, it gets again speeds up because the inner core is solid and the outer core is liquid. And that's how we reduce the internal structure of the Earth by interpreting the behavior of the seismic waves. Thank you everyone for